get back to the main backbone of our reasoning, just to fix a little bit what we've been doing. I know that the time is short, but I want to, let's say, to forward the matter. We'll go directly then to the how, and then we are back to the what. So I'm not following exactly the logic to the full sense, but I want to go straight to the design. So we have some time to talk about the design. So I repeat a little bit what we have as a backbone. Values, progress purpose and values, functions, high-level functions, breakdown in low-level functions, and then objects. So we started with either zero and Simosa. So basically in relationship to these purposes, to these boundaries in terms of high-level functions, eventually with the process view of things. So driven by it. We were thinking to, let's say, to move ahead in the how, when we were talking about either zero with more details, so more breakdowns, or other modeling languages like the event process chain. Because what I was showing to you until now, sorry, I was not starting the recording. I was saying that in the prior part, we've seen the, let me go through a little bit about images. We started with the identification of purposes, identification of boundaries, and either zero could help you because we have the context diagram, we can have high-level functions in that diagram. We can have also the purpose statement and the definition of the statement. So in that sense, something is covered by that. Simosa was presented to you as a different view to cover the same objective because the domain of Simosa in terms of domain process tell you about the boundaries. So simple. If you move ahead in the process, let's keep a little bit the discussion on value and so on. If you move ahead, we are having the definition of the requirements. The requirements means you are specifying how the system should operate. You can specify with a function. You have a functional modeling in terms of way to look at the system. You can specify in terms of processes if you are driven by events. So basically what we've done in the example in terms of either zero, if we break down and we go to more level, we are making basically some specification of the operational requirements with more things. If we're making at a different level of breakdown, IDF3 was not commented, but is majorly covered also by APC, event process chain, is a way to see the process that is implemented. Of course, you can break down also this into other models as well. Okay, so we're basically moving along the how when we're fixing the requirement. What means a requirement? The process should operate like this. When we have the arrival, we are able to follow this path. That's the requirement. And another requirement could be seen in the attached resources. We need the logistic department to execute this another requirement. So it's a perspective of the requirements you see depicted in the picture. If it's not given by the event process chain as a backbone that relates to requirements in terms of organization, requirements in terms of other resources, is a perspective in terms of other languages like, you know, that level zero, the requirements are basically seen in terms of, already know, in terms of flows. The different labels we see are basically the requirements to carry out the functions. So this is telling you the requirements, how they should operate, be operated. They're not the only view you may have. because requirements may be expressed, say, with different perspectives, but the function and process view are major one to know how the system works. Okay? Said this, now if we move ahead along the how, we switch from function to objects. This is majorly related to your question by me, human. That's the technique. It's very short in time, but I would like to present it as overall frame. Of course, if you need more reference of some insights, of course, it's a matter of looking at the references or asking. I would like to spend a little bit some time on this other language, but before spending this time, let you understand that first of all the different perspective. I'm using a picture that is here somewhere. Yeah. Until now, think about what we've done in terms of description in event process chain or in either zero. We were in this side of the picture. This is a pictorial representation of a process. You see, read from in a vertical way, it's similar to the event process chain. No? Of course, it's using icons, it's not so formal, but it's saying it's telling you the state. How the process should be operated. So to have, of course, the delivery of goods to the clients. And that's a functional oriented perspective, seen from the point of view of events. Okay? Can you follow this way to say? It's a way to see the world. You see the world in terms of events that require some functions. Okay? But the way to see the world could be exactly switched in another perspective, reverse way. You think about the objects that interact between them to carry out the process. It's a reverse way to see the things. So it's not about the function you have to play along the process, but it's about the object you have to involve in the process to contribute by means their interaction to the process realization. Okay? So that's the different worldview. You reason on the object. So at the end, the process you see here in terms of requirement, here, the process you see here in terms of what should be done is done because we have objects that are responsible to interact based on their responsibilities in the process, based on their capabilities in the process, because it should be kept. So we have different objects that interact to carry out the process. This perspective is what I would like to transfer. Useful. It's useful to make the design of a system that is made of objects that provide some capability, some functionality. So in that sense, I'm saying that we're moving ahead in the how. How in terms of operational requirements, go ahead, was discussed. And can have example like IDET zero and event process chain as typical tool that may represent this perspective. But it tells you how you should operate, what you have to do. This is a driving concept to select the object and allocate to the object what they should do. That's the design. No? Think I'm making an example from production systems. When I'm talking about the fact that I want to make a cutting operation, an assembling operation, and so on, I'm talking about what I want to do, requirement. When I'm talking about the machine or the robot or the cobot with the worker that I'm doing this, I'm having the perspective of the object that are assigned some construction. Okay? So the worldview of object-oriented, which comes from software engineering, totally different from production, but has been demonstrated to be valid for representing a complex system, also enterprises, manufacturing systems, whatever. So it's good, and in terms of software engineering, it has become one of the de facto methodology standard. It's well known, and it is quite flexible to be applied in different, let's say, complex projects where you have interactions between objects. So the process comes out from this interaction. How the methodology works. I was relating to some matter of fact which are related to the definition of complex system. We have technical complexity. Remember the very first consideration I did in the course. It's complex because it is structurally complex in terms of organization. So more a static complexity. It's complex because the complexity comes from the interaction more than complexity. So if you think that these are the two technical issues in terms of complexity of a system, if we have a methodology that covers these aspects, the structural complexity, behavioral complexity, is good. That's it. Okay? UML is a methodology, it's not one only language, it's a set of languages. I will give you some ideas of the possible languages you have. In this set of languages, it's covering a lot of aspects. So let's say it's covering the structure, it's covering the behavior. That's the point. UML stands for Unified Modeling Language. It is originally from the object-oriented, say, perspective in terms of software. Let me say that as an initial consideration, we may start from object-oriented programming, which is coding. But then after that, in the history, there was a development of object-oriented modeling, more as a conceptual modeling. It's not coding, it's a scheme. It's representing the logic. So UML is a result of this object-oriented modeling stream. It's not the programming itself, it's building the scheme of the system. Here, so when you're engineering a system, of course, UML is quite a de facto tool, but it could be applicable to other systems as well. Because the paradigm, the object-oriented paradigm is quite relevant for being applied to real systems. What is the idea behind, let me start from object-oriented programming first. The idea behind that is that what you develop as a software model starts from the fact that you transfer the real entity into objects, which are the correspondent entity in the software model. So if I have a car, I have a car in the software as an entity, the object. If I have a person, it's the object, and so on. Okay? So there is quite a good correspondence with respect to the real world because you have this mapping one-to-one real entity object in the software. That's the potential in terms of paradigm. Thinking about the object-oriented programming is a good forward to think how the scheme in the UML is done. So I talk about a little bit some concept in the programming, but just to give you the idea that is a forward for the scheme, for the conceptual models. What is the idea in terms of object-oriented? Is that we have an object, start from the object consideration. Then you will see that I will talk about class of objects, but it's another consideration later. What is an object? It is something which has an identity, myself and yourself, we are an identity. So it may be considered as something that has an identity by itself, can be identified. And as a number of, let's say, elements that are named as attributes and as methods. Let's understand the real meaning of those. Of course, this, let's say, is the terminology that is useful to think about programming. We have attributes, we have methods. Of course, these are also concepts. But let's understand what means having attributes. Means having a number of values that characterize your identity with some properties. If you're a car, you have red, white, or blue. You know, it's an attribute with the values. If you are a machine, you are located here or there. It's an attribute of the machine, and so on and so forth. So the attributes list is basically the information model that tells you the number of characteristics that give the property of the object. Okay? Beside the identity, it's more than that. And of course, in this sense, let me say, it's nothing different with respect to other languages that relate to databases. The concept of an entity that has an identity, some attributes is also valid for entity relationship. Concept is there. Anyway, it is important thinking about the object that if this attribute have two characteristics. One, you may think that they are hidden to the external world. You elaborate as an object this attribute. You update this attribute. You read this attribute. But what the external world see is the reaction to an event that comes from the external world. And this happens through the methods. And then you simple metaphor in analogy. We meet in the street. You say, hello. That's a message, no? And I not answer. There are some reasons behind that. Probably because of a mood. You don't see my mood, but you see the message that I'm giving you back. No message. No? But to say that what I'm receiving as a message activate a method and can have a reaction. In this extreme case, no reaction. No? But to say that this reaction depends on what I'm receiving as a message, what I have as attributes, and their current value of the attributes, the mood is not. Is black. Say. And the final result in the interaction, because it's an interaction, is that the method enabled to give kind of answer. So the logic in the object orientation is exactly this. An object hides, not visible, some attributes in the value it has, elaborates thanks to the methods, and may provide an answer to interact with respect to messages that are received from the outside. Okay? So if you see that sense, is that clear? No? Each object has its own attributes and methods that characterize in the full sense the object and enable the object to interact through this message passing back. Okay? So what I'm receiving is something which is a message, is equivalent to an event, and the message is an event that conveys some information. The message may have not only the event itself, but some information that is brought by the message. And this information may be useful for elaboration by means of the methods, may need some values in the attributes that is hidden in the object, and you may reply with an analysis. Okay? That's the object in terms of general sense. But in the end, if you see this, the object is an information model, the list of attributes, and a model of the behavior it can have. The methods that can be activated depending on the dynamics, on the events, on the messages that I'm receiving. Okay? And let me say also, on the status that is inside of myself. If my mood is black, it's black. So if I receive a message, hello, my answer depends on it.
I didn't really understand the role of attributes in this sense. Okay, messages activate methods, and if answers not, where are the attributes there?
In which sense?
I mean, because when we said the characteristics of the object, I mean, if they're static, like you said, the color of a car, I don't understand what's their role.
The attributes may have different, maybe different kind of properties. I will not express this, but I need to express. Some are static attributes, some are more dynamic. So in that sense, you have status that is changing. The single object has its own status tracked through some attributes. So in that sense, you may think about changing the status from black wood or no black wood.
So it enters in the answer part.
From the outside world, let's say, the message is received. The method may be able to interface with the message with the so elaborate message. The attributes may be useful to give an answer, but these attributes, depending on the value of the attributes, some of them may change through time, may give a different answer. I don't know if I just it. So some dynamics is there because let me express in another way, but suppose I was telling you. The dynamics is about the fact that from the external world I have messages that are received. So this may happen through time. I'm meeting you by chance now, not in another place. Here. The time consideration is also here because a subset of attributes is changing and characterizing the status. It may depend from your own internal event, the external. Okay? So this changing in the status is tracked by the object. So for this reason, you have a kind of dynamic sense behavior in the message passing and dynamic sense inside the object because there is a status that is tracked within some of the attributes. Okay? Of course, if it's static in the sense of red, it's red, the color. But if it's something which is dynamic, like a label, think about a vaccinated person. Not vaccinated, but vaccinated. This is also status. You move through the system, you are changing status. Okay? Is that clear? So, this was just introduced to object. The UML relies on the concept of class of objects. What means? We may think about a collection of objects that may be characterized by the same, in terms of structure, the same attribute list. And in terms of capabilities provided to the system in terms of methods. So, one class represents one object that are members of the same class because they share the common structure, attributes, and the common behavior, methods. Methods are like capability to answer with some procedure, with some routine. So in that sense, a picture of an object, in the end, if you want to go to the abstract level of class is more abstract than a single object. I am myself, I'm an object with an identity, with some given value, with some changing status. The class is the, let me say, the template that represents possible object like myself. So, if you see this, the example is an example of a car as an object. So the name of the class is the general car. Then you will have car with its own identity, which is the object. The car may have a list of attributes which tells about the essential information that are characterizing the information model of the object. Okay. So, for example, here, think about the dynamic. The owner may be changing. You can sell to another owner. This is an attribute that enables to track the status over time. But of course, now we should enter into the example that gives some meaning to the attributes. But just to think that this is an example that tells you some information model of the car. The power is given in the beginning of its build. So the model as well. So you may have some static information, static attribute, and some dynamic information that enables to track the status that can be changed. Okay? Here, this is just to reinforce a little bit in answering your question. Then there are some methods. So these methods, if you see, this is maybe algorithm to calculate the matriculation tax or whatever. But if you see more, let's say, in a general sense, independent of the software, let's think about an enterprise, let's think about the manufacturing system. No. The object has methods which are its own responsibilities to provide some services in the interaction with others. It's a responsibility to provide services. The method is this. If someone is asking me to a message something, I will have a responsibility to provide a service as an answer. Yes.
Method can then be linked to a behavior diagram?
Yes. Later, I will talk about some behavior diagram, proper question, because this method will be activated based on the message we are receiving. So I will skim later to say this, just to see in a tangible sense. But it's sure the fact of, about, see, we started from the paradigmatic perspective of an object, is one. And this implies that the method is activated if I'm receiving a message. This is already related to the Then we see a possible, let's say, modeling method to represent this. Okay? So, this is a kind of picture that tells you a model of the class of cars.
Sì, pronto?
The class that represents
Dimmi.
the so-called car in a generic sense, which has 4 attributes to represent the car and 2 methods that can be applied.
Ah, sì, deve entrare. Digli che entrino, ho capito. Macchi attiglio. Entrino.
Here.
Digli che vada dove deve andare.
So you see, methods, class name, attributes is basically a template where you represent the model of objects with common information model, common, let's say, capabilities or responsibility to provide this. Okay? But this is, of course, one part of the overall picture in the sense that it's one class of objects, but the reality is made by objects of different classes. So we may see the world as classes of objects that are related. There are different kinds of relationships. I'm not telling you the whole relationship, but I'm telling you that relationship may be, think in general sense, just to give you a link. Relationship can be of association. That means I am in this course, you are student and I'm the teacher. So there is some association between us. If I'm talking in general sense, there is the teacher associated to student of the class. So the class teacher and the class PhD candidate, and there is an association between them. Of course, this may be applied to any kind of system. If I'm entering into the shop floor in a production system, I know that there is some supervisor of the machines. So there is some class of worker, and there is a class of machine, and between them there is a relationship. This is represented by means of the association, which is one kind of relation. Other kinds of relation could be one object is composition of others. So this is two parts, and the assembly is the composition of 2 parts. So we have the class assembly and the class part. This pertains to the class part, this pertains to the class part, this pertains to the class assembly. So between class assembly and class part, there is a relationship of aggregation. We put together, compose. There are some distinction between aggregation and composition, but it's a detail. So I repeat, This is an object expression of a class assembly. Let's call it assembly. Both the twos are expression of a class which is part. The class assembly aggregates the class part. That's the relationship. Okay? So one kind of relationship is also this one. Third, important, it's represented here. It's more a kind of relationship that's related to another perspective of hierarchization. Remember the hierarchization I told you for the added zero? Also here is a hierarchization. Class, you see, this is a little bit of terminology, superclass class. Let me say that the concept is we have the general class, generic class, and we have the specific specialized class. For example, we have a sensor, is a general class. We have a pressure sensor, is a specific. Of course, we have a lot of objects that pertain to the pressure sensor class. But also the sensor itself is a class. Okay? So how to relate them? Sensor is the most generic class, is the superclass. Okay? Pressure sensor is a specific class. We can have also temperature sensor. We can have also, I don't know, other sensors. Okay? These are specific classes. What is the advantage of this relationship? It's a relationship that is also called the relationship of inheritance. What means? Remember that each class has attributes and methods that characterize the class. Okay? So, in principle, we can say the pressure sensor has attributes and methods. Temperature sensors is attributes and methods, but also the sensor is a general sense. Exactly. The logic that you have in the inheritance is if we place here in the superclass the attributes and methods that are common to the specific classes, they are inherited. So I'm saying, let's say, a simple attribute. The sensor has a location. It's an attribute. It does not depend on the fact that it's a pressure or is a temperature or whatever. It's valid for all. So this common attribute is in the sensor class, the superclass. The specific attribute will be related to pressure sensor. Okay? So the inheritance, what means? That the object that is created having an identity from a class inherits all the attributes that comes from the The location is in the sensor superclass. It is valid for the pressure sensor, yes, because it's inherited. And so the pressure sensor P1 has this attribute. Can you follow this? So this is a hierarchization. It's important to have this because this relationship, I told you in a brief sense, there are kinds of relationships and we can talk about them. But it's the way you create your model, UML model. In particular, the so-called UML class diagram. That's one model that you can develop with UML. Skip a little bit. Let's go here. It's very, let's say, it's an extract of a class diagram. Of course, it's very simple because of the objective of my presentation, but just to give you an idea. And what is telling you? The class equipment and the class worker. So first of all, you understood that each worker with an identity, each equipment with an identity will have this attributes list with a given value and with space. Okay? Here. Then there is this line connects the two classes. In this case, we have different symbolism for other cases. In this case, if I know the symbolism, this is a kind of relationship which is an association. Among the one who was mentioned is the association. And by the way, I have a class role. It's a label that tells you what is the role of this class with respect to the other. In the rule of the language, if we place this label close to this class, it means the role of this class with respect to the other. Okay? So the worker is a supervisor of equipment, it's obvious. He has this role. And is associated to this is the so-called cardinality. Again, there are some rules in the language that brings to write typically 1 star, this means one too many. 1, this means only one. And depending on where they're placed, it's a detail. I do not mind that they follow this detail, but just to think that there are these kind of rules. Depending where you place these, you can read the scheme. Say, let's make this simple exercise. What this means? That the worker is only one and is a supervisor associated to more than one machine. That's the way you read this. It's not the specific instance of the specific system. It's a design specification. It is telling you that we should have a worker that works as a supervisor with respect to more machines. How many machines? It's the next step. How many machines exactly supervisor is next step? Is the implementation. Is the understanding of your choices implemented in the specific system that has been manifested there. But the logic is the end. 1 to 9. Okay? Can you follow this? So, stop for a while just to think, to ask if there are some questions from the audience in the remote connection from here. Do you have any question, comment?
Maybe I have to try with an example. I need to try with an example.
Yes.
Because now it's clear, but when he have to try is another thing.
Okay. But I suppose it's clear that the object-oriented representation enables to do what? Because I would like to move a little bit ahead. To allocate to specific object what is needed to make a system. That's the point. Allocate to specific object what is needed to make a system. Each class has some method and some other. Seen from the point of view of the class is nothing, it's not the whole system. But if you combine the different classes related, each of them has started with some methods. So each of them has kind of capability that enables to be related to others. To fully understand the picture, we need to think about these objects in the dynamics, in the behaviors. So it's exactly the point you're raising. This is another scheme. It's named as sequence diagram. It's one of the diagrams beside the class diagram you may have here. Okay? This scheme is telling you again the classes. So we're reasoning at the level, in this picture, at the level of the classes of objects. So we already know that a class may have attributes and methods. Here we see just the interaction over time between these classes. Describing the sequence diagram from reading in vertical way is like thinking about the timeline. Okay. Reading in the horizontal way is thinking about the exchanges of messages between objects. So you see, I'm back to the vertical way, you see the sequence of messages that have been exchanged, which is the time realization of the process. The sequence of messages is the process. Okay, so it's behavior. But how the process can happen? Because this tells you that there is an interaction of messages, so some exchange between achievement controller part worker, and the time is evolving. Okay? How to make it happen? Because when the object is receiving a message, like the part is receiving a message, it has a method to make something. So it has a method to make something. So this is the point, in the sense that each object receiving a message, the message can be broadcasted to all the objects, but some of them may have some impact managed by them.
Those could be seen as the controllers.
Sorry?
Those could be seen as the controllers of the other methodology, the ones that came from the top.
This one?
Now, each point that receives the class, so you mark it in there as
this one?
Yeah.
This is just the destination, the receiver point. So normally the message is generated by one object, like here in the tail, the equipment is generating the messages, and can be sent to one or more objects or classes. In this case, it's an example, it's sent just to the point. In another case, it's broadcasted to all. See the controller, I'm broadcasting the message to all the objects. All the three other objects are receiving the message. Okay? So in some cases, you are sending a message directly to one, in other cases, you are broadcasting to one. What means? If I'm sending a message to someone, this means that I should need a method to manage the message. The object that is receiving the message has a method. Then the method could be only an update of attributes. It is making the update internal to the object, not necessarily providing an output. But it's update. I don't know if I answered you.
No, yes, I was just thinking if this could be mapped into the other methodology that we were saying before, the one that has the square, it has the input and on the upper side of the square, really. Yeah.
The event process chain, you mean?
No, it was the that
Box for my
that one. So the ones that the event that is being triggered, yeah.
Here is a message probably to answer to you.
Yeah.
Let me just conclude this point, but here is the answer. Understood. Let me just conclude a little bit this point, because I want just to give you a brief note on this. This sequence diagram may be used to show the collaboration through messages between objects. So, reading in an overall sense is like saying, we have time that is advanced. We are exchanging messages which can be seen as events, and we have the object that should be able to receive the message, elaborate upon the message, change something internal to the object, and if needed, give it feedback. Not necessary. Okay? So this is telling you that the objects are interacting through messages with other objects, and to make the interaction, they need some method to elaborate it. Okay? Now, let's see the broad sense of this. This method is a summary of all the responsibility I may have. What means? If you think about the dynamic with other objects, the whole possible dynamics, not only one. The methods may be able to may enable to interpret. So the given, let's say, receiver start operation is a message from a controller. It should have a corresponding start operation, sprint and start production. That basically is the method to elaborate the message that is received by means of this. So the message you have corresponds to some method that provides the response. Okay? So this means also that if you elaborate different sequence diagrams, it's like showing different scenarios of dynamics between objects. Not only one. This is the one that ends up well, but imagine the case of a failure. If you have a failure, it's another scenario. There is no failure in this collaboration diagram, the second diagram. No? If there is a failure, it will be another scenario. If you superimpose the different scenarios, this brings to require in the class diagram to have a number of capabilities which are methods that act upon outputs. So in an iteration of the development, you may think that we developed sequence diagram to express the dynamics. We fulfill what is needed by the object to be able to interact with the scenario. So the methods, imagine, first we were empty, then we are adding some methods according to the messages to the message. Can you follow this iteration? So probably it's answering to your question, right?
But for instance, if we have a fault, then we have to draw another sequence diagram in the case of a fault.
Yes, because this is not represented. It could be another one that will tell you how the dynamics between objects will end up with a fault. And it will bring some method here in, like request repair. So, fulfill the scenarios in the sequence diagram and complete the class diagram with the methods that are required for all the scenarios. In an integrative way, the class integrates the scenarios. Okay? Yeah? There is another, let's say, diagram. Let me tell you briefly this one. Not only the sequence diagram is good, there is a diagram which reasons about state transition. It's not originally from UML, but it's embedded in the methodology. It's more from automation, let's say. But indeed, if you think about these are representative of the state in which a specific object can be. It can be idle, not working, busy, with a piece processor, repair, under repair, which is of course after a fault. To move through the states, you have the so-called transition. So you may interpret this like something that is happening instantly. Okay? In the transition, you may label a number of information. In a general sense, one is the event, so same concept as discussed. Another could be an action that is done, so it's associated to the event. So failure, you do the action of requesting the event. In a discrete sense, it's done in the transition. Of course, it requires some time, but it's discretized in the transition. Okay? And you may have also, between parentheses, some condition, if it is the case, to represent the condition, logic condition to follow the transition. This means that if the condition is respected, you can follow the transition, otherwise not. Okay? So it's the condition that comes from the same object, other object. Okay? So this is also a representation of dynamics, but if, as you see applied, it is more the representation of the internal dynamics of the object. The object moves from idle to busy to repair through the transition. In this case, there are some, say, permanent cycle because you're not never ending, it's continuous. There are different kinds of state transition types. Okay? If you see the label, in the end, you will recognize that this label have same consideration, end operation, start operation as before. If you see from the external side, these are messages exchanged. If you see on the internal side, these are transitions in there. If you see in the class diagram, these are the methods. No? So, what is the message I would like to transfer here? That the class diagram, of course, it is quite complex in the sense that it has more classes, more relationships. And for each of them, you have methods and attributes. Is the full sense of the object, the orient model of the system to be designed. Why? You have the attributes that are the characteristic characterizing each object. You have the relation, you have the methods. So this is the full sense of the design. No? To get to this full sense, you may need to, let's say, elicit the right from the dynamics. That's the idea. To build up sequence diagram, you think about the exchanges that are done. You may find state transition diagrams to explain better the internal behavior. This gives you input for fulfilling the task. No? And this is the result of what? It's a translation of what I expressed in terms of requirements in the real picture. I will do this process. But how to make it? By means of interaction of workers, equipment, part. So I'm moving from the functional perspective to the object perspective. Can you follow this? Here we are in the how. Very close to the deadline. This one. Questions? I have 15 minutes. I suggest like this. I give you a brief note of what is missing. I would eventually record a little bit some other consideration, so to leave you free and put in the report. Just be the problem. Depends on. Question until here? So, from the audience? I would spend 10 minutes to give you an overview of what is missing. I will probably complete in the next days. Next week, I will make just a quick recording of what I believe to transfer in an offline way. I think I would integrate 20 minutes more today. Because I would like just to conclude today, just to give you the overview and just general message of the calls for success. Okay? It's more important this one in presence. So, very briefly, less than 10 minutes, it's very hard to make it. But I would like to give you the logic, and then I will find some time to record and give you offline. Again, I do not pretend to have the full picture, but you understood that I'm following a kind of logic that is given by these pages. So, repeating a little bit. If we start with this statement of the purpose, identification of the boundaries, we can start from the functional perspective. In context diagram, zero can be a way to think Simosa with the maze can be another way of doing it. If we move along the how, we move from operational requirements, what we want to do, think about item zero again, think about event process chain, think about other languages. Instead of event process chain, there is BPMN, business process modeling notation, which is well used in business process. But it's not different from APC in the concept, in the objective. Okay? If you move in the design, it's a matter of identifying what we need from the different objects. Think about the UML cluster. Think about the next step we discussed. But I was skipping totally this part, which in concept was already transferred to you, but a little bit the method could be covered now in this very quick one. What you're doing when you're here, we are trying to understand what is more important for the stakeholders. Because these at the end are driving the whole engineering. Second, if you think more specifically, they may define the criteria upon which you decide you decide that the system is good or not. I want to reach some targets. This depends on the stakeholder. I will evaluate that this target is achieved. This depends on the evaluation we will make later, but it should be related to the target fixed by the stakeholder. Okay. So in this part, you have these two kinds of objectives we would like to reach. In the presentation, I have, let's say, two methods, quality function deployment and analytic hierarchy process. Then for two problems that are very much related to the values of the functions, but not in the how perspective, but more in the why. So it's here. We're here with a ASP with a quality function. Quality function deployment was developed in a context of product development. Sorry for the wording, but it was at that time developed to support the product innovation, starting from the voice of the customer, so listening to what the customer wants, and arriving to what is important to develop. It has some systematic iterative approach based on the definition of a matrix. You have the idea of the iterative approach here. The matrix is repeated in a kind of recursive way. The matrix should be explained. Let me say it's a technical explanation, so I could leave you in the recording the technical explanation of this. It's a matter of detail, but now I need to give you the key message. What is the key message? Apart from let's say, the repetition of this, the key message is that we have a way to relate what we want to achieve to the way to achieve. And in this, we want to give a kind of rating of importance. Because at the end, when you're engineering something, you should decide in which part you have to invest. You need the prioritization. To have the prioritization, you should need, on one end, know what's the what, which is see from the customer perspective, what is required, what he wants. And not only the what's in a general sense, the what's with some prioritization. So also could be interesting that the customer tells us, or we are able to extract from the customer, that some items are more important than others in the what's. Okay? Then, of course, one may say, I would like to how to express the what's. The what's can be typically expressed through functions. The customer wants to make something with the system. So these items may be prioritized in terms of giving a rating. In the sense that one function is more important than the other. Still, they're not done with the quality function deployment because we know the item to be obtained, but we should relate this to some characteristic of the design that enables to obtain them. Not in detail, but I want to play with this without breaking that. This depends on the characteristic of the cell phone. It's a silly case, but just to say, the size is not 4. Size is a characteristic of the out. Is a technical characteristic. Is a measurable characteristic. It's not what the customer wants. Of course, with my ages, this is a more intelligent case. As it's the size helps me to look at it. The size helps me to digit. If it was small, probably it was not. No? So think about what the customer wants and how this can be achieved. What is the item in terms of functionality make? How is the characteristic? Okay. Personally speaking, I had to buy to my mother, which is more than 80 years old. I had to decide to change it from a smartphone to a normal phone. But it's obvious. There are different what's. So I needed to change to different hours. Different salary. Not smart. Here, that's probably the most intelligent example I could make now. But this is the point. I will tell you in a more technical detail about the fact that the stakeholder should give a rating to the relationship. That's the point. Between the what's what I want to do, and the how, what is the characteristic of the tool, what the system is. Typically, like I will show you in the recording, the QFT or other methods are making some rating system based on some scoring and some scale that gives you the meaning of the score. It's not a mathematical model. It's not important to have the exact magnitude of the value. No, it's important to have the relative comparison. So, saying this, I will tell you how to get to this, but saying this, it is the result of a rating system. And knowing the rating system in this case means that 90 is the highest score, which means that looking at the column, and knowing that this is the characteristic of the cellular phone, is the most important characteristic to invest on because you are reaching more value, because this is the value, 90 is the value for the watts. Can you follow this? The watts is representative of what the customer wants, the value, or the functionality with some value. They are what you can do to reach the value. And 90 is the highest score. Is that important as a value of 90? No, it's important the relative order, the relative mark. Here, that's an example that comes from new product development. And let me say also, to open a little bit the link, value engineering. You make product and you're driven by the value, not by the cost. Of course, cost is part of the equation at the end, because you may have some constraint on the budget and so on. But in this evaluation, the 90 tells you about what you want to provide to the customer. AHP is another rating system that has been developed for decision-making problem. In 1 minute, it's difficult. I will not tell you the way of doing the AHP, again, recording. I will tell you the general meaning. If you have a decision, even your own life, you have more criteria to decide upon. You have different decision criteria. You combine the car, the one that is having high performance, speed, the one that is reliable, the one with enough consumption. You can have a number of criteria. Note that these criteria are exactly the characteristics that relate to the concept of value. Remember the Oxford Dictionary definition. The value is the regard that you may deserve to a thing, the usefulness. It's reliable, it's speedy, it's low consumption. These are characteristics. So the decision criteria, you might think that they are values characteristics. The HP helps you to make a decision based on multiple criteria with some method. It's one technique among others that helps you to make multi-criteria decisions. I will tell you a little bit more about the HP, but remember that it's not the only technique. But it's important to think that it's another kind, in general sense, of rating system that enables you to make kind of rating of the decision criteria which are competing on a decision. And this decision criteria may be, at least we think about this recently for the open course. So, looking at the example, the decision is to select an aircraft. You see that the decision criteria are expressed there in the picture. With some method, you will apply multi-criteria distribution. Okay? Okay. I stop here. We'll provide with some recording next week. I will find some time when to make this recording. Say that it's 30 minutes or something more. So to give you more insights on these two parts that are missing. That's it. I could say a few words. First asking you, you have received the valid course assessment. I told you, my idea is that next week we can take time if we have some problem in finding a group. Have you already done? You have here, for example, people here. Are you having already some idea of group? In the process. Problem of people of 2 persons or 3 persons or more, or you're finding a way to have 3 persons or more? You're more or less in convergence.
Yes.
From the remote connection, maybe because remote means also people that are always remotely. You want to say something in terms of finding groups? Feel free, because it's a way to try to convergence, to do a convergence. I received from one of you some consideration. Answer at this moment flexibly.
Yes, this morning I send you an email. I don't know how is the solution, but I am waiting you about it.
Okay, but I would understand if there are someone also in individual cases, because in this moment, as far as I understood, even you are coming from the industrial company, of course you are in an individual case. So
beh,
possibilities to join another group or to do individually. But I'm
I don't
pushing
know.
one decision.
Maybe
Are there any other people individual in this moment, or you are in the process of deciding? Just to understand if there are some individuals, only individuals. No?
for me is maybe it's the best thing to make an individual task about the exercise. For example, the lesson of the today is very right for the project you have described in the mail.
Maybe we can have some meeting point next week with you.
Okay.
Yeah.
Uh,
So
I,
I would say that
I
if
send
you
you
agree,
email and
yes.
to accord the meeting.
If you agree, we can do like this, because of course I don't want to push a solution, but I want to, let's say, act as a mediator, essentially, to find a good solution. So if some of you have started on forming a group because maybe you have not found a group, you can write by mail, so we see what are the situation. I can accept also individual. It's just to understand the way of doing it, so to balance, let's say, the objective of the course assessment. Doing individually has some constraint. Is not gaining benefit of interacting with others, but I understand that, of course, each of you may have a constraint, and so important to let me understand next week if you have problems specific, because typically you're individuals, tell me. If this is ongoing, I'll let you next week to develop further. Informally, let me say, you can communicate also the group by mail, so I know that the group have been formed. I would say that formally, I will ask you to fulfill a form, because these are exactly to establish, let's say, the group. But to me, just to manage this, let's say, this convergence, it's okay also if you have decided at least anticipate me my mail, so I know that some groups are already, let's say, in place. Okay? These are just to manage in the next week eventual need for convergence. That's it. For the course assessment, let me say that there was a written text where it is specified. You understand that we talk about different topics in a general sense, system engineering, design science research, in more technical sense, data-driven simulation, modeling, in terms of formal models I was discussing. Any of this is a content that you may use, maybe combining, so to fit your own problem you would select, your own problem. Fitting means that you will be deciding in the group. What I will ask in the form is to anticipate some draft idea, in the sense that, for example, I'm still defining the form, but I will ask you probably a checklist of keywords so to select the topic you expect to discuss. Simulation, not so this means to me to organize a little bit also the next stages. Okay. In terms of dates, negotiation, of course, is there, but it's we are quite flexible except one matter. We need to deliver your own evaluation before some deadline, because then you have to deliver to the evaluation for your yearly evaluation. In management engineering, in our case, I know what could be the deadline because I'm also fixing it. But indeed, I would say that we can take as maximum, let's say, latest date also the first week of September, October, sorry, as latest. I don't know if some of you, for example, in mechanical engineering, I don't know will have the deadlines, but are similar. I don't know if people from the other universities have some specific deadline to conclude the evaluation for this year, or October first week at latest can be also good for you.
I can answer for Perugia University. I need to send everything until the end of the September.
End of September.
End of September.
Okay. I would say that, okay, we keep the first week of October just for flexibility. Our idea, discussed with Elisa and Andrea, was to, let's say, fix some weeks, second part of September. I would say the 1st of October could be a flexibility in the sense that we place the presentation, because what we expect is a presentation of the group in these 3 weeks. Let's say the most, let's say, we will try to make it in September for the all. We have some problem, of course, when we speak to October for others. Of course, respecting your own constraint first. If it's okay like this, we can fix the time frame from middle of September to first week of October. Most probably to make the presentation along the 2 last weeks of September. Okay. Before that, we need to receive the presentation. I know that this is will create a negotiation, of course. I received the preference from the others. I'm a little bit more flexible, so probably I will say it there. They asked me to tell you end of August. Too much? First week of September. You should leave us 1 week at least in advance. First week of September. Okay, I will send you by email some dates for the time. Okay, I will check exactly the dates, so maybe it's not exactly the first week. I'm negotiating that. Okay, is that okay?
Okay.
Okay, I hope you got something from this course. Of course, it is compressed in some ways. It is not the intention to go in deep in some concept because, of course, it's time is the daily. But at least it gives you some ideas and links to focus on specific methods if there is. In general, I do believe that this is brought to you not only for making research, it's for making practical engineering. Of course, having the perspective of PhD that has, let's say, a leading role in the research. So, in that sense, sometimes we were not saying all details, but giving you the link of something which maybe is useful to explore. Okay? So it was a pleasure. I hope you appreciate it. Thank you. Have a nice weekend to all of you.
To you, thank you very much.
Thank you.
Thank you so much. Bye bye.
Bye-bye.
Thank you, boy.
Dai.